Hello everyone, it's been a while. Today I want to continue on talking about PKDSA, but this time it is about customization and key recovering. Most likely I will repeat this in future video on PKDSA. For a time being, I don't really know whether advanced mentioning is a good or bad idea. PKDSA uses a portion of second type of CKMS and some portions of DKMS. When this video comes out, video which describes KMS may not even exist yet. The term user secret may be too technical for most of the folks. User secret generally consists of two types. One is biology data from man. One is private identities from man. One may propose to use DNA or fingerprint or voice or facial image from man to act as a data source for the private key on the client device. That is much more easier to use compared to current default user secretless approach. What users or providers may not realize is that the biological data from man are always data that is way too critical and sensitive to handle by any cybersecurity approaches or methods. Using this data to act as a source for private key is something that gives a visual of big question mark as to whether this approach will pass regulations. Let's say that miraculously regulations to allow and there are experts who really can safeguard this highly critical and sensitive data. This data by their own cannot be replaced. You can assume it like your fingerprint or your DNA. For sure, you can use it to create a very strong and random private key, which you don't need to afraid that you can't recover your private key. The question from me is that, can you replace your fingerprint or DNA once hackers crack your private key by brute forcing the submitted public key? People tend to opt for ease of use, familiarity, and convenience. But the point from me is, do men really come to a point that we also willing to have these three aspects by completely ignoring on what is valuable or sensitive to us? The other part of user secret is private identities. If data leakages or breaches to occur, provider indeed require the private identities from users. This was needed because the provider need to address on data availability and integrity issues. Data availability and integrity actually have 50% respectively. 25% of data availability and integrity could be addressed by using clustering and regular cybersecurity procedures. The other 25% of data availability and integrity needs to be addressed by using private identities from users or clients. There is an extreme irony here. If private identities were requested and stored, in an instant, 50% of both data availability and integrity respectively could be achieved. However, in reality, it is still 25% of data availability and integrity being achieved. 50% is only the case when resources is severely limited. The question which I think might be worth in asking is, do people still want to submit their private identities given that there is a portion of users or clients are concerning on varying scale of data analysis, and companies or cybersecurity experts do nothing to reduce the amount of identities being leaked on a daily basis. Incompetence, ignorance, and insufficient skills might be something that I can think at this point of time. If the users or clients do still want to submit identity, try to shift away from current private identities such as email and phone numbers. Possible identities could be sessions user ID, anonymized email after using VPNs, and Tor together. If the users or clients still want to submit private identity such as email, what you can do is to urge them to use provider such as ProtonMail. In either case, when the client or user submitted their identity, those identities automatically become public data regardless of how one tries to convince you that is not really the case. Curve 25519 and Curve 448 allows the users or developers to customize on how they wish to generate private keys. There are numerous ways to generate private keys. These are the common methods that I can think at this point of time. Passwords, passphrase, seed, and CRNG. Each of these methods have their own pros and cons. I will dive into each of them one by one. If password or passphrase and seed was not hard-coded or visible in the code, then this data will most likely stored as string or text in files. Seed can be in both string or mutable data format when storing in files, C#, as CRNG generate random mutable data as private key and store them into files. These three methods, when storing the data in files, they all share a problem in which how do the program know which files to look for in the operating system. The location needs to be known by the program and the operating system. This opens up attacks for the attackers. The location of the private data for private key is something that can't be addressed or solved. Password or passphrase provides recoverability on private key regardless if they were stored in files or typed by users or clients. However, password is less secure than passphrase if we count in their cryptography strength, covered in some of my videos. Proper dealing, storing, and managing password or passphrase have slowly been transformed into a task that its requirements are becoming more and more absurd. There are no fixed standards on how to properly deal with password or passphrase. The maximum security is confined by how many computational resources can the device allocate. PKDSA script Argon 2. It is very easy to mess up in proper dealing with passwords or passphrase by using cryptography algorithms. You also can't limit on the password in such a way that only random and strong password or passphrase was allowed. A wrong choice in Choosing password or passphrase for the private key can cause easy access to other platforms which use passwords as authentication, given that the users do not follow proper security guidelines and their private key has been brutally brute forced. Developers or providers can also configure the client application in such a way that it uses custom supplied seed from the users or clients. Ideally, it is best that the seed is given and stored in mutable data format in files. The seed can then be used to generate limitless amount of private keys and provide recoverability. The cons of using this method: if the seed could be figured by the attacker, or the generated private keys could be rendered useless. There are also proper cryptography approaches that one needs to follow in order to use seed to generate limitless amount of private keys. Both passwords or passphrase and seed provide recoverability, but they can be described with putting all eggs in one basket. Using CRNG might be the most secure, but it has a problem of not being able to recover private key if the private key was lost. I highly advise that developers or providers to use mutable data type in dealing with private keys and storing them in files. These three approaches come with their own pros and cons. Pick your own poison is a term that I think could be applied here. These three approaches allow the replacement of private keys, unlike using biological data, which is one of the form of user secret. That is all for this part. Thank you very much.